Hi, in today's video we will be going over confidence intervals for quantitative variables, specifically the state, plan, do, and conclude portions. In the state section, there are two things you want to have, the first being the parameter we're estimating. For example, we want to estimate the true mean of pages we have to print in a class with a 95% confidence interval. Also, if you need to state a hypothesis, you would state them here. In the plan section, we are going to be writing the appropriate inference method. For example, mean intervals with a 1, 2, or matched error sample. Then, you check the conditions, which we will be going over on the next slide. We will also want to add some more context for the problem. For one sample test, it will need to be random, normal, which means the sample is greater than 30, and independent, where the sample is less than 10% of the population. For a two-sample test, it'll also need to be random. It'll have to be close to normal with little skewness and no outliers, and it will also have to be independent, where the sample is less than 10% of the population.
For the do portion, start by writing down the equations you will be using and by listing all the variables needed to solve, including the mean, sample standard deviation, degrees of freedom, critical value, whether that's a z-star or t-star value, and the sample size. After finding all these values, substitute them into your calculator and you should get an answer. Now for the equations. This equation for the confidence interval will follow this format. Statistic plus or minus critical value times standard deviation of the statistic. Now for a one sample mean, the standard deviation of the statistic will be the sample standard deviation over the square root of the sample size. But for a two sample mean, for a confidence interval, you'll take the square root of the first sample standard deviation squared over its sample size plus the second sample standard deviation squared over its sample size. Now, the degrees of freedom will also vary between the two. So the degrees of freedom for one sample mean will be just n-1, but for a two sample mean, you'll take the smaller value of n-1 for each sample size. Now, note that when you're using a z-interval, you need to use the population standard deviation and not the sample standard deviation.
Okay, so now the final step is to interpret the interval in context. So if we're going to use the previous example, we could possibly say we are 95% confident that the interval of blank to blank contains the true mean of papers needed to print for the class, or whatever the parameter happens to be. But don't forget to add context and explain what the conclusion means relative to the problem. So, as a quick side note, a couple common errors include forgetting to add context, plugging in values into the calculator incorrectly, forgetting degrees of freedom or a critical value, using the wrong table, or mixing up statistics with parameters with correct notation and such. To avoid these errors, be sure to show all your work and be deliberate. Plus, if you have extra time, it is recommended that you do each question both on paper and using your calculator. This will ensure you catch possible errors and can double check your work. Now, we're going to be going over how you can use your calculator to solve these problems.
To do a one-sample z-test for mean, go to Stat on your calculator and then go to Tests by clicking right twice. Press number 7 on your keyboard to take you to the 7th option on the menu, which is the z-interval test, and then make sure you lock onto Stats. You want to enter values then for the population standard deviation, the population mean, and the population size. Notice it's population mean, size, and standard deviation because this is a z-test. Then enter the confidence interval as a value out of 1. This is a 95% confidence interval, and calculate. To do a one-sample t-test for mean, again go to Stat and go to Test again, but this time press 8 to take you to the 8th option on the menu, which reads t-interval. Make sure you lock into Stats again, and then enter the sample standard deviation, the sample mean, and sample sizes. This is samples because it is a t-test, not a z-test. In z-test you take population size, here you take sample size, and the confidence interval is the same thing. It's a value out of 1 for whatever confidence interval you're testing, and you can calculate, and then you're done. Two-sample z-test for mean is very similar to one sample. Again, you go to Stat, you go to Tests, this time selecting option 9. You are asked to input, again, the population standard deviation, mean, and population size, but you want to do that for both your samples. So you just enter the standard deviation for both, the mean for the first one and the population size for the first one, the mean for the second one and population size for the second one. Then it will take you to the confidence interval, same as before. Enter a value out of 1 for whatever your confidence level is, and then calculate. The 2-sample t-test for means is very much like the 1-sample t-test. You want to go to stat again, go to tests, and this time enter 0 for the desired field to appear. Make sure you're locked into stats, and then begin entering the sample mean, sample standard deviation, and sample size for the 2 samples that you're comparing. Make sure that the confidence level is again where you want it, at a number between 0 and 1, and then go and indicate whether the data is pooled, yes or no, and then you can calculate.
Right, now that we've gotten through the video, if you guys are looking for more practice, number 2 on the 2017 FRQ and number 5 on the 2016 FRQ are great practice. The problems and their answers will be linked in the description below. Thank you for listening.